So welcome back, guys. We are recording. We're going to do a few more. Well, this one looks ugly enough, 57. So somebody is not unmuted, guys. I can hear something in the background. If you don't mind muting yourself, we are recording. No big deal. Mistakes happen. I've done that, I'm sure, in the past. Thank you. All right, guys, welcome back. We are continuing our work. This is July 10th, and I'm kind of saying it because I have to organize all the videos. Sometimes they go to the wrong folder. I'm just reminding myself. All right, guys, so we're going to work on it. All right. We are talking about inverse functions. We are working on 3.2. I'm going to write this whole thing and say this is equal to sine theta. I'm going to call it theta. Okay, I'm going to say this is theta. And this one will probably be a little challenging. I don't remember. I did it a long time ago. And based on this, I can easily say sine theta, defining by the definition of inverse function, is 2 square root of 5 over 5. I can say that. Of course, theta is in the right place. Of course, theta is in the right place. Okay? Now, what did this become? This whole inside is theta. This becomes secant theta. This automatically now turns out to be secant theta. Okay. If I can find sine theta, I can find cosecant theta. If I know cosine theta, I can find secant theta. So bear with me. This is a little extra work, okay? Well, it's not really extra work. This is not a number from the unit circle. All right? 1 over square root of 5 over 5. It's not a unit circle number, but it's okay. Don't panic. We'll get through it. What are we going to do? Well, we have done this in chapter 2. We're going to use our identity. I don't even need the unit circle. I do want to keep it because I might need it for the next problem. I do know my theta is in the right half. That's something I know. It's either here or here. Okay. Remember this formula, guys? Actually, guys, I'm going to go to a new slide. Okay. So bear with me. I'm going to remember this formula. Cosine. It's called trig identity. Theta plus sine square theta is equal to 1. And very patiently, we're going to use this to find cosine square theta. So I'm going to go back and forth, back and forth. I'm going to take this. This is something I know. It's something I derived 2 seconds ago. I know sine theta is 2 times square root of 5 over 2. Now, just to let you know, this can be written as 2 over square root of 5. I like that better for now. Why? Because I want to keep things simple. Now here, I'm going to write cosine square theta plus, instead of sine square theta, I'm going to write 2 over this. Why? Because sine theta is 2 over square root of 5, I square it. Now, 2 squared is 4. And square root of 5 squared is 5. All right. Now, so far so good. I'm going to subtract 4/5 from both sides. And if you do your fractions, hopefully you know how to calculate fractions, you can of course use online calculators. There are tons of them, but I know it's going to be 1/5. Now, you want cosine theta. If you can find cosine theta, you can easily find the reciprocal and find secant. That's what we're looking for. But you take the square root of both sides. Cosine theta is square. We're taking the square root of both sides is going to be this. But don't forget the plus minus. When you take cosine, you're always running into this plus minus thing. Now you might say, well, my answer should be unique. It can be plus minus. I agree. Now I'm going to go back. Remember, guys, we told you it's in this quadrant. We told you based on what sine is, theta has to be in this quadrant or this quadrant, to be honest. It doesn't really matter. Okay. Cosine will always be positive because in the first and the fourth quadrant, cosine is positive. That's why. That's how I know it is positive, and I don't have to guess. If you guess, half the time you'll be wrong. So I'm going to say, okay, now I know for sure. I don't need plus minus. It is plus. Now I have the cosine value. With me so far? Don't worry about the radicalizing the denominator. We have the cosine value. I'm going to take the cosine value and go back to my original problem. What do I want, guys? I found the cosine value. I want the secant value. Well, easy. If cosine is 1 over square root of 5, secant is going to be reciprocal of that, which simply means square root of 5. Done. Got it. Now I'm going to check my answer. Okay. 57, and I hope I got it right. Not bad. There, see, here they're finding plus minus square root of 5, then they're concluding it's only plus. So make sure you get that. I'm going to pause there a little bit. It takes a little bit of time to do these problems. I'll do at least 2 more today. And I'm doing some of the hardest ones just so that you're aware of it. Okay. For this very problem, you really don't need the unit circle. You do need to know what's in first quadrant, what's in the second quadrant, what's in the fourth quadrant. Either I sometimes say the right half or the top half. If things are in the unit circle, you're better off. If things are not in the unit circle, you're going to use the trig identities to solve them. And what are the trig identities? Let's go back and review for a second. It's something we did a long time ago. These are the trig identities. Okay. Sine squared theta plus cosine squared theta is 1. And you can write it like this if you want to. The orange ones are called derived. You don't have to know, just move things around. You just memorize the blue ones. Tan squared theta plus 1 is secant squared theta. And cosine squared theta. The next one, I know you can't see it fully, but don't worry. If we need it, we'll bring it to our slide screen. All right, guys, let's do one more. We'll do 2 more. Let's do the next one. Oh, let's do something. Of course, you can pick. This one looks interesting. This is actually not a number from the trig from the unit circle. So let's do 52. One thing I'm a little confused about. 57, 58. Okay, they're the numbers are a little random here because of the way I copy pasted it. It has nothing to do with anything. Don't worry. Let's do 52. Looks ugly enough to me. I don't think this will be too bad. Okay, 52. Yeah, we did 57. We're kind of going back. Don't worry. This whole inverse thing, I'm going to call it theta. I'm going to say sine inverse. I'm going to say this is theta. All right, I'm going to make it bigger. Don't worry. All right, so guys, based on the definition of inverse function, theta has to be on the right half of the unit circle. And not only that, we can also say this. So they're trying to trick us with this problem, okay? I don't think square root of 2 over, oh no, it's not too bad. We might, no, square root of 2 over 3, is it a unit circle number? No, They are trying to, I think they're trying to trick us. Don't worry. Don't worry. We'll survive. I wish my computer screen was a little bigger. 3, 2. All right. So I can say that theta being on the right side. Okay. Square root of 2 over 3 is really not here. Okay. It looks like it's a number from the unit circle. It's not. Now, the question is, this guy, original problem, now turns into this problem, which is not too bad. I can simply use my trig identity to find cosine theta, and I have to be aware that since it's sine theta, it's in the right half, and cosine on the right-hand side is going to be positive. I already know it's the theta answer. When I find the square root, it's going to be positive. So let's come here. Let's bring this guy here to our next page. All right, this came from the previous slide. Now I know sine theta, sine square theta is what? Well, sine square theta if you square square root of 2, you're going to get 2. If you square 3, you're going to get 9. And then if you subtract 2 9s from both sides, because you're solving for cosine, and you get 7 over 9. All right? You get 7 over 9. Now you have to find the square root of 7 over 9 to get cosine value. And that's going to be square root of 7 divided by square root of 9 is 3. And let's put plus minus here now. Let's put it. Okay. Now, the point is, I do know theta is in the right-hand side. Let's bring our unit circle. Here. So on the right-hand side, theta has cosine has to be positive. It won't let me make it smaller. Okay, now it's better. So I don't need plus minus. And that has to be my answer if I didn't make a mistake, guys. This is my answer. Cosine theta is square root of 7 over 3. That's cosine theta. I found it. And this is 52. Let's go look. Yeah, square root of 7 over 3. That's your 52, square root of 7 over 3. That's your answer. So I'm going to pause it a little bit. Okay, I'm going to do one more problem before we call it day today. And this is how hard it'll be. It won't be much harder than this. Okay, I'm going to do one that will involve a trig ratio other than sine squared theta plus cosine squared theta. Let's go find it. I hope I can find it. From cosine to cot. This may be one of those. Let me see what else is going on. Okay, I'm going to assign you way too many problems. So let's try this one. If you know cosine, you have to find cotangent. Okay, let's do 56. I don't know what it is, but it will be hard. Okay, actually 55. Let's do 55. We have done one like 56. Let's do 55 because from tan to sine, I think we'll have to use a trig ratio that's different from the one we use. Let me try this. And you can always tell me to do certain problems. If not today, maybe next class. All right. So the inverse part is defined as theta, tan inverse -3 is theta. All right. So tan theta by default or by the definition, I have to put a minus sign here. -1 inverse. So by default, this is tan theta is -3. Now, if tan theta is -3, this guy, top guy, the real question turns into sine theta. Now, how do I go from tan theta to sine theta? Not so obvious. Remember our trig identities? So, and we'll go to our third slide today. Okay, so I know tan value. I can find secant. If I can find secant, I can find cosine, sine, doesn't matter. Okay, so that's the argument. Tan squared theta plus 1 is secant squared theta. So I'm going to go to this part. Actually, guys, I'll delete it. I'll open a new slide. All right, so coming back here, I know tan theta, I want to find sine theta. No big deal, we'll find it. And this is a good problem. It's actually one of the harder ones. So you have to just be a little patient, okay? From tan, and again, tan is on the right-hand side. You can't forget that. So I do know tan squared theta from my trig identity. Tan squared theta takes 1 is equal to secant square theta minus 1. Now, you can write it as tan squared theta plus 1 is equal to secant squared theta, but this is a little easier. Now, instead of tan squared theta, I am going to write -3 squared, which is going to be 9. Which is going to be 9. Which is going to be 9. I'm going to add 1 to both sides, and I'm going to get secant squared theta is 10. Let me make sure I didn't make a mistake, okay? Give me 1 second to check my work. I think that's about right. Now I'm going to find the square root of 10. So secant theta is square root of 10. I'm going to stick a plus minus here. All right. Now that I have my plus minus, secant is the reciprocal of cosine, okay? Tan theta, this theta being on the right half, cosine and secant will always be plus. So I'm going to get rid of this. So secant theta is 1 square root of 10. Now, from secant, I'm going to go quickly find cosine. I'm going to go quickly find cosine because it's just the reciprocal. Now that we have cosine, we're almost done, guys, except for we need sine. Now, you can do this problem in 2 ways. One is you can use this first one. Okay, if you know sine, you can find cosine. If you know cosine, you can find sine. Or you can use the very definition of tan from, you know, the value of tan. And I'll do it the second way. So this is your cosine value, right? You know your tan value, and you know tan is, you know tan theta is sine theta over cosine theta. All right. So, you know, remember, guys, in the question, tan theta is -3. So let me see where I can do it. I'm going to actually do it here. Okay, that way we can kind of keep track where things are. So this is part 2, and this is our final part. Instead of tan theta, I can write -3 and instead of cosine theta, I can write 1 over square root of 3, or 1 over square root of 10. Now, if I multiply left and right, cross multiplication, whatever you want to call it, whatever your teacher taught you, you can say sine theta is equal to -3 times square root of 1 over square root of 10 is going to turn out to be this. This is going to be your answer. Okay, they wanted to find, let's go over it. I'm going to bring it to the next question. I'll put it right across our question. They wanted you to find this mess. And based on how you defined it, it turned out to be sine theta. And by doing all the work we have done, sine theta is -3 over 10. I'm going to go back and check my answer. 55. I hope I didn't mess up. Yeah. Okay. So -3, I got -3 over 10, but we have to remember, guys, we have to rationalize the denominator. So let's go ahead and do it. So we got the right answer. So you multiply top and bottom by square root of 3, and you're going to get -3 square root of 10. And these problems are a little difficult, I know. So I know it's probably a little too small, but let me see if I can make it a little bigger for you guys. Oh boy, it's supposed to be big. So this is our answer, guys, and it's correct. So rationalize the denominator. It's a lot of work, okay? And that's why in math, you don't want to forget the things you've done in the past. So we're kind of relying on chapter 2 a lot. That's all the, excuse me, guys. That's all the lesson I have for you today. I'm going to jump out of this session. I'll be back. We still have about 35 minutes. If you want to hang around with me, if you want to chit chat with me, please be available. I won't record anything. I don't think I will, but I'll see you next class if I don't see you during the next session. But thank you again for coming. See you later.